Good day, class. So here is our sample problems for your module 3 torsion. So we will solve the sample problems. So first is figure A shows a 2-inch diameter solid steel that is built into the support at C and subjected to the torque TA and TB. So determine the maximum shear stress in segment AB and BC of the cylinder. And second, compute the angle of rotation of end A. Use G is equal to 12 times 10 raised to 6 psi for steel. Okay? So before we can compute the maximum shear and the angle of rotation of end A, so first, we will draw the free body diagram of the whole cylinder. So we have the dito yung figure natin dito sa may left side. We have the three free body diagram. So first is yung ating whole cylinder and kung ano yung mga nag-act na torque sa kanila. So for torque A and torque B. So therefore, by equilibrium, we can compute na yung torque at na torque acting at C will be 500 pound-feet. So kung makikita nyo, for simpler, for counterclockwise, that will be positive, and for the counterclockwise, that will be negative. Okay? So, computing therefore for the torque at point C, so that will be 900 minus 400 pound-feet. So therefore, yung torque at C natin will be 500 pound-feet acting at counterclockwise. Okay? So for simplicity is we've changed into vector yung ating torque. So going to the right side, that is positive, and going to the left side, that is negative. Okay? So therefore, yung ating torque at C is 500 pound-feet clockwise. Okay? So we have the in the middle segment, so that is the internal force. So parang yung sa stress din natin, i-isolate na yung segment AB. So i-cut natin siya into section. Then if our torque at A is 900 pound-feet counterclockwise, therefore yung ating internal torque at segment AB will be 900 pound-feet clockwise. Okay? And for the segment BC naman, so for segment BC, so we will cut the section in between BC. So we have torque at point A, that is 900 pound-feet, and torque at B is 400 feet clockwise naman siya. So TA will be positive and TB will be negative. Therefore, yung ating torque at BC will be 500 pound-feet acting clockwise, okay, in segment BC. So ayun, using the right hand rule ito, no? Pag right hand rule, so kung saan nakatutok yung sa may right hand nyo, so yung right thumb ninyo, okay, so yung rotation niya, that will be kapag counterclockwise, that is positive, okay, and for the clockwise, that is negative. Okay, so let us continue. So in solving the maximum shear stress, sabi natin yung formula natin for maximum shear stress, so that will be for shear stress, that is equal to TR over J. Tama? So kunin natin yung maximum shear stress in segment AB. So before that, kunin muna given na yung ating torque. Okay? So yung torque natin will be 900, and so for TAB, that is equal to 900 pound-feet, and for TBC, that is equal to 500 pound-feet. Okay? And for the polar moment of inertia, which is yung J, so yung ating cylinder is solid siya. So yung formula natin for J, that will be J is equal to pi d raised to 4 over 32. So given yung ating diameter, that is 2 inch in diameter. So yung polar moment of inertia natin, J, that is equal to pi times the diameter, which is 2 inch, raised to 4 over 32. Therefore, our polar moment of inertia is equal to 1.5708 inch raised to 4. Okay. Therefore, we can compute the maximum shearing stress at segment AB. So, maximum shearing stress at segment AB. So, shearing stress max at AB, that is equal to yung torque at AB times yung kanyang radius over the polar moment of inertia. So that is equal to, so yung torque AB natin, that is 900 pound-feet. So that will be 900. So convert natin siya sa inch, no? So para maging consistent yung unit natin. So let's multiply it by 12. Okay, to convert it into inch. So that will be 900 times 12 times yung kanyang radius. So yung diameter natin is 2 inch, therefore radius is 1 inch. So times 1 over our polar moment of inertia, that is 1.5708 inch raised to 4. So our max shearing stress at segment AB, that is equal to 6,880 psi. Okay. And for the maximum shearing stress for segment BC, so that is equal to, so our torque is 500 pound per feet. So convert ulit natin yan into inches. So that will be 500 times 12. So isa lang din yung kanyang radius, that is 1 inch over yung kanyang polar moment of inertia, 1.5708 inch raised to 4. Therefore, yung kanyang maximum shearing stress will be 3,820 psi. Okay? So for part 2, so compute the angle of rotation of end A. So let's compute the angle of rotation. So yung angle ng rotation natin, so actually the angle of rotation at end A is equal siya sa summation ng ating angle of twist of the two segments. So yung angle of twist ng A, B, plus yung angle of twist ng ating segment B, C. Okay? So ang formula natin for angle of twist, that is TL over JG. Okay? So that will be equal to theta A is equal to yung TL over JG ng ating segment AB plus TL over JG ng ating segment BC. Okay? So substitute lang natin yung ating mga given. So that will be the angle of rotation is equal to, so for the torque 900, convert natin ulit sa inches, so times 12, and yung length ng ating cylinder, that is equal to for segment AB, that is 5 feet. Tama? So yung length natin for segment AB, that is 5 feet. So multiplied by 12 ulit para maging inches. Yan. Over yung ating JG. So pagsamahin na natin, si isa lang yung kanyang JG. JG, so that will be plus, so the other one is 500 times 12 times yung length niya, that is 3 feet, so times 12 ulit, over yung G natin, that is 12 times 10 raised to 6 times yung J, that is the polar moment of inertia, 1.5708 inch raised to 4. Okay? So therefore, yung ating angle of twist at end A that is equal to 0.04584 radians, or that is equal to 2.63 degrees. Okay, so this will be our final answers. So for problem 2, so the shaft in figure A consists of a 3-inch diameter aluminum segment that is rigidly joined to a 2-inch diameter steel segment. So the ends of the shaft are attached to a rigid supports. Calculate the maximum shear stress developed in each segment when the torque T is equal to 10 kPa/inch is applied. Use G 4 times 10 raised to 6 psi for aluminum, and G for steel is 12,000 times 10 raised to 6 psi. So we have a two segment here for aluminum and for steel, and magkaiba yung kanilang diameter. So before we can calculate the maximum shear stress in each segment, so kailangan nating kunin yung kanilang yung internal torque na nag-act sa aluminum and yung internal torque na nag-act dun sa ating steel. Okay? So for equilibrium equation, so ito yung FBD natin. So if we have a 10 kPa/inch na torque, so syempre i-resist yun ng ating aluminum and ng ating steel at both ends. So kunin natin yung external torque at aluminum at dun sa ating steel, dun sa in both supports. Tama? So for equilibrium, summation of moment x, okay, that is equal to 0. So that will be equal to counterclockwise positive. So gawin na lang natin na clockwise positive. Okay, that will be clockwise positive. Therefore torque at steel minus yung ating 10 kPa/inch, so 10 kPa/inch plus yung ating torque at aluminum that is equal to 0, no? So simplifying our equation, that will be equal to torque ng ating steel plus yung torque ng ating aluminum that is equal to 10 kPa/inch. So that will be times 10 raised to 3 para maging pounds-inch na lang siya. Okay? So ito yung magiging ating first equation. So meron tayong, so for equilibrium, meron lang tayong isang equation, no? With two unknowns. So we can use again yung ating principle of compatibility. For compatibility, yung angle of rotation ng ating steel, okay, is also equal sa dun sa angle of twist then nung ating aluminum. Tama? So sabi natin yung angle of rotation that is equal to TL over JG. So TL over JG ng ating steel, okay, that is equal to TL over JG ng ating aluminum. So that is for compatibility. Okay? So for them to be compatible, dapat parehas yung kanilang angle of rotation, okay, or yung angle of twist. Therefore, pwede nating makuha yung torsion ng steel in terms of torsion ng aluminum, okay, using itong formula na to. So i-substitute na lang natin yung ating mga given. So that will be, so let us substitute the given. So that will be torque ng ating steel is equal to yung length ng ating steel, so that will be 6 feet. Okay, so 3 feet pala. Okay, that is 3 feet. So 3 feet times 12 para maging inches over yung G nung steel. So that is G for steel is 12 times 10 raised to 6 psi. So 12 times 10 raised to 6. And yung polar moment of inertia, so sabi natin yung formula natin for the polar moment of inertia. For polar moment of inertia, that is equal to pi d raised to 4 over 32 for solid. Okay, so this is for the solid cylinder. Therefore, substitute na natin. That will be pi over 32 times yung diameter natin. So that is 2 inch. So times 2 raised to 4. Okay, so this is equal to the torsion of the aluminum times yung kanyang length. So that is 6 times 12 para maging inch. So there at yung kanyang G, that is 4 times 10 raised to 6. And yung polar moment of inertia for aluminum, that is pi over 32 times yung kanyang diameter, that is for diameter ng ating steel, that is 3. So that will be 3 raised to 4. Okay, therefore we can compute yung ating torque ng steel in terms of the torque of aluminum. So for simplifying yung ating equations, so that will give us torque ng steel is equal to 1.1852 torque ng aluminum. Okay, so nagkaroon tayo ng second equation, and we can substitute yung second equation dun sa ating first equation. Tama? So let us substitute yung equation 2 sa equation 1 natin. So we can compute torque ng steel plus torque ng aluminum. So yung torque ng steel natin, meron tayong torque ng steel in terms of torque ng aluminum. So i-substitute na lang natin. So that will be torque ng steel is 1.1852 torque ng aluminum plus yung torque ng aluminum is equal to 10 times 10 raised to 3. Tama ba? Ayan. So we can compute yung torque ng aluminum. So that will be equal to 4,576 pounds inch. So we can solve both. That will be yung torque ng ating steel will be also equal to 5,424 pound inch. Okay, so therefore we can compute the maximum shear stress in each segment. Okay, so using yung ating torsion formula, so that will be maximum shear stress. So first is yung for aluminum, so that will be equal to, so yung formula natin, that is 16T over pi d cube. Tama? So that will be 16 times yung torque ng aluminum, that is 4,576 pound inch over pi times yung kanyang diameter. So the diameter for aluminum is 3 inch. Tama? So for aluminum, that is 3 inch times 3 raised to 3. Therefore, yung max shear stress natin sa segment ng aluminum, that is equal to 863 psi. And for the maximum shear stress for the segment ng ating steel, so that is equal to, substitute nyo na lang yung mga given. So that will be 16 times yung ating torque sa steel, that is 5,424 over pi, yung diameter ng ating steel, that is 2 inch raised to 3. So that will give us 3,450 psi. Okay, so ito na yung ating maximum shear stress for steel and for aluminum. So for your next problem, so the 4 rigid gears loaded as shown in figure A are attached to a 2-inch diameter steel shaft. So compute the angle of rotation of gear A relative to gear D. So use G is equal to 12 times 10 raised to 6 psi for the shaft. Okay, so compute the angle of rotation of gear A relative to gear D. So actually yung ating angle of rotation, so the angle of rotation ng gear D relative to A, okay, so that is equal to yung summation lang ng ating angle of rotation for segment AB, BC, and CD. So angle of rotation ng AB plus angle of rotation sa BC and angle of rotation sa CD. Okay? So, before we can get the angle of rotation, so angle of rotation is equal to TL over JG. So, we need to compute for the torque na nag-act sa ating shaft. So, yung mga internal torque na nag-act. So, first is we can convert ito into a linear vector para mas madali nating makuha yung nag-act sa ating mga segment. Okay? So, ito na yung FBD niya. Itong nandito sa right side. So, first is yung ating segment CD. Okay? So, ang gawin natin for kung nakaharap tayo dito sa ating A, so that will be counterclockwise. For counterclockwise, so that is going to the right using the right hand rule. Okay? So we can compute yung ating torque at segment CD. So isi-section lang natin. So if this is 500 pounds, so that will be 500 pounds. So for torque at CD, so that is equal to 500 pounds. So minus 900 plus 1,000. Okay. Therefore, yung ating torque at segment CD is equal to 500 pound-feet. Okay. And for the segment BC, so for the torque at BC, so that is equal to, so i-section na lang ulit natin yan. So yung matitira for segment BC is yung ating 500 pound-feet, so that will be 500 pound-feet minus yung ating 900. Therefore, yung ating segment BC, so our segment BC, that is equal to negative 400. Okay, 400 pound-feet. So yung negative indicates that yung ating segment BC is opposite siya doon sa kanyang direction na na-assume. Okay, so that will be for torque BC. And for the torque AB, so that is equal to, so kung 500 pound-feet yon, so yung internal torque AB natin will be also 500 pounds. Okay? So, ayun. So, nakuha na natin yung torque AB, CD, and BC. Now, we can compute yung kanilang angle of rotation. Ano? And yung angle of rotation natin at point A relative to gear D is yun yung pinaka-whole na angle rotation. So, yung summation lang ng ating angle of twist sa bawat segment. Okay? So, substitute na natin. So, that will be angle of twist of A relative to B relative to D. Okay? Is yung kanyang summation lang ng mga angle of twist ng each segment. So that will be angle of twist ng ating AB plus angle of twist ng BC and angle of twist ng CD. Okay? So substitute na lang natin. So that is equal to TL over JG ng ating AB. So that will be yung T natin sa AB, that is 500 pounds. So 500 pounds. Yung length niya, so yung length niya is 5 feet. So that is times 5. So i-convert natin ng inch, so that will be times 12 natin. And itong 500 natin is 500 pound-feet, no? Naka-pound-feet ito. So, naka-pound-feet yung ating unit sa torque. Therefore, i-multiply ulit natin sila ng times 12. Tama? Para maging inches din. Times 12 over yung polar moment of inertia, so that is equal to, so iisa na lang yung kanilang polar moment of inertia and iisa na lang din yung kanilang G. So isa-summation na lang natin yung kanilang torque and yung length. Okay? So that will be for segment BC, that is 400. So actually yung 400 natin is negative because it is against dun sa kanyang direction. So that will be negative. So minus 400 times yung length niya. So i-convert natin to ng 12 ay ng feet. So that will be times 12 din. So gayahin natin yung na dun sa module nyo. So times 12 para maging inch times yung kanyang length, that is 3 feet. So times 12 para maging inch din. Okay. And for the last segment, that is CD, so that is plus, so yung kanyang torque, that is 600 pound-feet. So times 12 para maging inch times yung kanyang length, that is 4 feet, times 12 ulit over yung kanilang G and yung polar moment of inertia. So for G is isa lang, that is 12 times 10 raised to 6, and yung polar moment of inertia, that is pi over 32 times yung kanyang diameter, that is 2 inch raised to 4. Therefore we can compute na yung ating angle of rotation at end A relative to angle of rotation of A relative to D, that is equal to 0.02827, or that this is in radians. Okay, so actually this is in radians, so we can convert it into degrees, or that is equal to 1.620 degrees. Okay, so ito na yung ating angle of rotation at end A relative to D. Okay,